Let's go ahead and get started. We have such a short class. We are not going to do too much. We just need to cover the make your own table. So if you'll turn to right here. Okay, last class, we learned how to do Riemann sums, but you already had the table. So what we're going to do today is that we're going to make our own tables and then just still do a Riemann sum. So let's say that you want to do y equals x squared. Do you know the shape of that graph?
Absolutely. It's the U, right?
It is the U. Very good. Thank you.
Such an expert.
You are the expert. Okay, y equals x squared looks like that. And then we want to find the integral from 0 to 8. Okay. Okay, which would be, let's say, here's 0, here's 8. Okay. Now, at this point, you have already learned how to calculate an integral, but you can still do Riemann sums even if you have the equation. Okay, you would just use your own table. So the first step is going to be to find the width of the subinterval. And I think I gave you an equation for this last time, but it's b minus a over n. Okay, where b minus a is going to be the total width of the interval. And then you're going to divide it into n pieces. So that's going to be the number of subintervals. And then this is going to be the total width. So let me show you what I mean by that in part A. We want to integrate 0 to 8 using 4 subintervals. You would say your width is going to be 8 minus 0 divided by 4. Where the total width from 0 to 8 is 8 units across, but we want to divide it into 4 equal pieces. So what is 8 divided by 4? 2. And then you're going to construct a table that starts at 0, bless you, counts by 2, and then stops at 8. Then to get the y values that you need over here, okay, you're going to just plug them in one at a time to your equation, which in this case we know is y equals x squared. So let's do 0 first. What's 0 squared? 0. 2 squared? 4 squared? 6 squared is, and 8 squared is 64. Okay, then we're constructing a left Riemann sum, which y value will never get used based on the notes last time. For a left Riemann sum, who never gets used? Okay, you're going to skip the last y value for a left. Okay, and here's why if you don't remember. From 0 to 2, my left side y value would be 0. 2 to 4, it'd be 4. 4 to 6, it'd be 16. 6 to 8, it'd be 36. But my 84 is never a left side because it's the last point. So let's set up our Riemann sum. 0 to 8 of x squared dx is approximated by, okay, keep in mind, this is not the actual area. This is an estimate of the area. Okay, what is my width from here to here? 2. And then what's my left side y value? So 2 times 0 plus 2 to 4 is another width of 2. Left side y value is 4. Okay, 4 to 6 is another width of 2 with a left y value of 16. And then 6 to 8 is 2 with a left side y value of 36. Now, I can't remember if we did this last time, but do you remember that if the width is always 2, you can just DCF it out? So in your calculator, okay, I'm going to put, or you could do 2 and then just add up the 0, the 4, the 16, and the 36. Okay, which I would say that is easier, but you could do either one. Okay, now let's do B. Almost the same question, except now I want 8 subintervals. So here's what's going to change. I'm still going 0 to 8. My width is still going to be 0 to 8, but I want to divide it into 8 pieces. 8 minus 0 is 8, divided into 8 equal pieces. How wide is each piece? 1. So I'm going to have to go back to my chart and kind of fill in the gaps and say, I don't want to count by 2 anymore. Now I need to go 0, 1, 2, 3, 4. So I'm just going to use the same chart, but kind of squeeze them in there. Okay, so put your odds in there. And then we're going to put our y values in there as well. So 1 squared would still be a 1. 3 squared would be 9. 5 squared is 25. And then 7 squared is 49. Okay, so it looks a little ugly, but that way we don't have to remake the whole table. For a right Riemann sum, who gets skipped, first or last? First. So I'm never going to use the 0, but I'm going to add up all of these y values. And then what is the width, which is always the same since I made my own table? The width was 1. Very good. So you would do 1 is pulled out. So 0 to 8, x squared, approximated by 1 is my width. And then I would add up 1 plus 4 plus 9 plus 16, 25, 36, 49, 64. Okay, but notice that for left side, you skip the last one. For right side, you skip the first one. That's why 0 never made it into my sum. Okay. All right, for a midpoint, we'll do a midpoint on the next page. Let's go down to D. So this time my equation is cosine x, and I want to use 4 equal subintervals. So set up your width equation. Remember, it's b minus a over n. What is my b minus a going to be? Put the numbers in there for me. 2 minus 0 divided into how many subintervals? 4. 2 minus 0 is 2, divided by 4 is 0.5. So in your chart, you're going to start at 0, you're going to count by 0.5s, and you're going to stop at 2. So set that up over here to the side. We're going to start at 0. So 0.5, 1.0, 1.5, then 2. No, we're doing a left. I skipped the midpoint. And then how will I get those y values? I'll plug them into the equation, which in this case is cosine x. So let's do that on your calculator. Go into your calculator and put this in as your y1. So your y1 needs to be cosine. Okay, then to adjust your table settings, you're going to hit second window, and you'll see that right above that in blue, it says table set. That's table settings. You're going to adjust your little triangle. That's a delta. That represents the change that it's going to jump by. So I don't want it to jump by 1 each time. I want it to jump by 0.5 each time. So y equals is cosine x. And then you're changing your little triangle to a 0.5 so that now in your chart, do you see that it's jumping by 0.5 each time? Okay. And then that's what you want. So at 0, I see my y value is a 1, 0.8776, 0.5403, 0.0707. And now, do I really need to record the value for 2?
No.
If it's a left, am I going to use it? No. So you can put it if you want, but you're not going to actually use that one. Okay. Then from there, I'm going to put my width in the front. What is my width every time? 1/2 or 0.5. And then I'm going to add up all of the y values except the last one because it's a left. So it'd be 1 plus 0.8776, 0.5403 and 0.0707. Okay, then if this was your homework, okay, which obviously it's not, you would add this up and then round to the third decimal place. Now, I want you to notice in fifth period, we had a couple of issues that if you round these to the third decimal and then add them up, you could end up with a rounding error where your answer is close to right, but it's off. So when you do it in the calculator, go to 4 decimals. That way you have like a buffer for your rounding error that it'll come out right every time. So then you would add these up, round to 3. Good? All right, turn the page. Okay, we're gonna do maybe one more with a midpoint Riemann sum. Okay, but I want to kind of change the numbers on this a little bit. So take a look at your next question. It's 1 to 3. We're gonna make that, let's go 1 to 5. And then let's divide it into 6 equal subintervals. Okay. And then we're going to use a midpoint. Okay. So first question, how do I find my width? So I'm going to do 5 minus 1 over 6. That's 4 divided by 6. 2/3. And then this isn't going to come out as nice as I want, but it's fine. Okay, so then 2/3 is going to be my width. So go into your y equals. We're going to make e to the x our main function. And then I'm going to change my delta to be 2/3. Okay, so I'm going to hit second table set. And I'm going to make this 2 over 3. Oh, I think it's a pretty fraction. Okay, well, we'll just have to estimate. So put 2/3 there. Okay, then I want you to make your table, but I want you to kind of space it out. So my graph has to start at 1, and then I notice, is 1 in my chart? No, and I need my table to start at 1 and stop at 5. So what you're going to do is go back into your second table set, and you're going to change your start value to 1. So the bottom number tells you what you're skipping by, and this is going to tell you your starting x value. Okay. So now when I go over here to my graph, I'm going to put 1, 1.6, 2.3, 3, 4.3, and then 5. And now notice, I know that I can stop at 5 because that's the top of my integral. I'm just going from 1 to 5. Okay, then here's the problem. This is a midpoint sum. So if I go from 1 to 1.6, do you notice that what this midpoint is? It's missing. That's not going to work. What would be halfway between 1 and 1.6? 1.3. So if you're doing a midpoint, you're going to come back into your table set, and you're actually going to have to make your jumps half of that so that you can skip 1. So it would be 1/3. That way I can see what these little gap numbers are. Does that make sense? Okay, but you'd only have to do the half if it's a midpoint. So now I can see, between 1 and 1.6, my y value at 1.3 is 3.7937. And then from 1.6 to 2.3, I can see that there's a 2 in between that at 7.3891. Okay, but you would only have to do that for a midpoint question. Okay, my next one between 2.3 and 3 would be 2.6. It would be 14 point. Now, remember what I said, your calculator, you have to go to 4 decimals to make sure your answer doesn't come out wrong. So if you highlight the number, you can see the extra digit. So it's gonna round it here because you only have so much space in your table, but if you highlight it, you can pull the full decimal. So it should be 14.3919. Okay, and then the last one that I need is, oh wait, we have two more. Between 3 and 3.6 is 3.3. My Y value is 28.0316. And then before 3.3 and 5, I would want 3.6. I don't know, remember?
There's two values between 3 and 4.
3. Oh, dang it, I missed one. It's fine, we're just gonna pretend. Okay. So then for 4.3 to 5, I would use 4.6, which is 106.342. Yeah, I accidentally skipped one. Okay, but you get the idea. Okay, then from here, you would set up your Riemann sum. Your delta X is still 2/3. We had to have the table count by 1/3, so we had those middle numbers. But remember, your width is still here to here. So you would set it up. It would be 0.666 or 2/3. And then you would add this guy, this guy, this guy, this guy, this guy, and then the one that I accidentally skipped. Okay, you get the idea? Or no?
I don't understand why there's two values in the thing, like some of those.
It's because I messed up. So what should have happened is from 4.3, it should have gone to 4.6. But I just forgot to write it. So really there's a 4.6 here. And then remember for midpoint, when you go from 1 to 1.6, you have to use the middle Y value between them. So that is where I messed up. So it should have gone from 3 to 3.6. And then from 3.6, it should have gone to 4, right? No, to 3.9. I don't know. Look at my table. So it should have gone 2.6, 3, 3.3. And then 3.6, and then 4, and then 4. Yeah, so I just messed up. But can you see it on here?
Why did you like things the way you do it? Why did you make everything like why did you do it?
Why didn't you just move
Oh,
it up?
why did you like?
Why did we count by 0.3 instead of 2/3?
Yeah.
The reason why is because for a midpoint sum, you have to skip one in the middle to use its Y value. So y'all, since I've messed this up, let's just do the one on your homework where it doesn't look ugly. So will you pull out your Chromebook? And the first make your own table is a midpoint. Let's just do that one together so you have one example that's not all messed up.
Is it the one that's past due or you?
I think it is past due, but I'll adjust it. But it's the Riemann Sums homework.
We're doing the second table.
The first make your own table.
I like.
Should be this one right here.
Right.
Okay. We're doing the first make your own table off the homework. And then y'all have the rest of the time to just kind of work on stuff. Good. Thank you. 3:30. All right. So first thing I want you to do is in your calculator, type in the equation, which is x to the 4. Okay, put it in your y equals. Okay, so you're going to put y equals x to the 4. Okay, then from there, go into second table set. Where does my integral start? What number? So I'm going to let my table start be a 0. Okay, then what do I want it to count by? I have to find my width, which is b minus a over n. Okay, it is going to be 1/2. Here's why. What's 2 minus 0? 2 divided into, oops, not 5 equal parts. What's 2 divided by 5? So it's b minus a over n. So it'd be 2 minus 0 divided into 5 parts. So it'd be 0.4. Let's just make it a decimal. Okay, 2 divided by 5 is 0.4. Okay, on your paper sketch, you're going to start at 0. You're going to count by 0.4s. So 0.4. Let's do this more carefully than I did the last example. 0.8. What would be 0.4 after 0.8? 1.2. Then what? 1.6. Then stopping at 2. Okay, then here's the problem for midpoints that doesn't happen on the other Riemann sums. When I go from 0 to 0.4, what x do I want to use its y value for? It has to be the midpoint. What's halfway between 0 and 0.4? 0.2 is who I want the y value for. And then from here to here, what y value do I want? 0.6. So when I go into my table, instead of putting 0.4, I'm going to 0.2 my triangle so that I can see what those midpoints are. And then hit second graph. So at 0.2, I see that my y value is 0.0016. Then from 0.4 to 0.8, my midpoint is 0.6, which is 0.1296. From 0.8 to 1.2, what's my midpoint that I want the y value for? So it'd be 1, which would be 1. And then from 12 to 16, my middle point would be 14 with a decimal in it. And then I'm going to pull that number out of the chart. So it's 3.8416. Last one for 1.8 is my last midpoint. Now notice it's only giving me 3 decimals here. It's going to mess up your answer. You have to highlight the number and go to 4. So on my 10.498, I see that that's really 10.4976. Okay. And then from there, you're ready to do your sum. What is my width for each interval? 0.4, because remember, I had to put 0.2 so I could see the midpoint, but my width is 0.4. And then I'm just going to add up these midpoint values. Also, quick little hint here. If you used 5 subintervals, you should be adding 5 numbers. Okay. So my 0.0016, 0.1296, 1, 3.8416, and 10.4976. Okay. Then it's going to ask you to round it to the thousandth. That's 3 decimal places. So my 6.188 will stay because it's followed by a 1. Does that make sense now that we did it right? Okay. But remember, it's your width on the outside and then adding your y values on the inside. And you make your own tables, your width will always be the same. Okay. Oh, I went too many numbers, huh? This should be a 9. Thank you. All right, next one you said? Okay, so go into your y equals. What are you going to make your equation? 5 root x. And then what's my width going to be? Do b minus a is 5 minus 2 is 3. And then I want to divide it into how many pieces? So what am I going to skip by? 1. So for my chart, I'll just kind of scribble it here. Okay, I want to start at 2. Stop at 5, and I want to count by 1 each time. So 2, 3, 4, 5. Okay, now I'm doing a right Riemann sum that I don't have to worry about, ooh, what about what's in the middle? Does that make sense? If it's a left or right, you don't have to worry about that. So in your calculator, you're gonna go into your table. Okay, if you wanna adjust your table set, you wanna start at 2 and you wanna count by 1 this time. So that you don't have a bunch of extra numbers that you don't actually need. Okay, and then I'm gonna pull those numbers out of the table, going to the 4th decimal each time. So at 2, I want 7.0710.
Isn't it?
It is, so we'll end up skipping, you're right, the first one. Okay, then 8.6603. Oh, you're right, it is 1. Okay, and then for my 11.18, make sure, don't round it to 11.18, you need to use the full decimal. So it's 11.1803. Okay, now technically you are adding them up, but then you also need to multiply by the width. But what is the width in this instance? A 1. So that's why in this case, if you forget to put the 1 in the front, it actually won't matter. Then you'll add those guys up. So 7.7. Yeah, don't include the 7, because it was a right Riemann sum. Is that right? Yeah. There we go. So you should get 29.840 followed by a 6. That would go to 29.841. Okay, but if you give yourself that 4th decimal as a buffer, then you won't have any rounding errors. Okay. Yeah, that's the second make your own table. Yes, do you do you want to do one? Emily, you wanted to do one of those too, right? One of the graphs at the end? Oh, without the graph? Okay. So like this one? Okay. All right. Are you ready to do this one with me? Okay. The second one, everyone has a different question, so we'd have to do the first one. Okay, so do you remember the formula for average value? So it was 1 over b minus a integral a to b. Huh? 1 over 2 minus -3, correct? 2 minus -3 integral -3 to 2 x squared minus 4. Okay, so you said this first fraction is a 5th. That's correct. And then for this part, you're going to take the antiderivative. So what would that be? So add 1, then divide. 1/3 x divide 3. Don't need the plus c. Then we're going to plug in 2, -3, and then subtract those values. Then don't forget to divide by 5. Good. Let's do 2 first. 2 cubed. What is it? 8 times it by 1/3. It would be 8/3. Okay, minus. Then 4 times 2 is an 8. And I would just leave it just like that.
That's what I did.
So then for -3 cubed would be -27. And then divide it by 3, it'd be a -9. -3 times -4 would be a +12, right? And then -9 plus 12, that would give us 3. Okay, then from there, you're doing this minus that. So what is minus the whole numbers part? What is -8 minus 3? So it's really 8/3 minus 11. And then you would get a common denominator from there. And so then we'd make this times 3 times 3, top and bottom. So now my 11 is a 33/3. Does that make sense? And then what's 8/3 minus 33/3? Wouldn't it be, 25? Okay, then don't forget, what did I have in the very front weighting? The 1/5 means that I would essentially just either times the bottom by 5, or if I can divide by 5, then do it. So if this is a 25 and I want to fifth it, what would that top be now? -5/3. Does that make sense? So you do have to kind of muddle through the fractions a little bit.
I
Yeah. Yeah, it should be -5/3 is right. And then Dua, you wanted to do one too? The graphs. You want to do the first one? Okay, so it's asking you for the average value. So remember, average value is that formula we just did. So it'd be 1/b minus a. And then integral a to b. So in this case, if I'm going from -8 to 8, what would my equation be? 1/8 minus -8, and then integral -8 to 8, right? So what is that first number going to come out to be if it's basically 8 plus 8? On the bottom. 16th, and then for this part, rather than you doing a big complicated fundamental theorem, you'll just do the areas. So they're telling you here that the area, the first one is a 5. Notice it counts as a +5. Then B is a 6. We'll have to minus that one. And then 15 and 25. So let's add, what's 5 plus 15 plus 25? Add the 3 positive areas. 45, and then take away the negative area 6. You can use a calculator too if you want. So here, let's just add them. We had an area of 5 minus 6 plus 15 plus 25. So my total area is 39. And then I would have to just remember to divide that by 16. So it'd be 39 or 16. And now if this could reduce, you should do it. But if it won't, then you can leave it. Sure.